We continue with 3.4. So this is complex numbers. So let's have a look. It's 5 marks. The impedance of a circuit is given by the equation. So Vt, that's probably total voltage, is equal to V2 divided by V3 plus V1. Okay. So calculate the total Vt. If V1 is equal to 3 plus J, V2 3 plus J2, that means 2 times J. Same thing, it is not J squared. This is not a square, be careful. If it is a square, it must be written as a small 2 on top there. Right, so J2 and 2J mean the same thing. Last one is 2 minus 3J. So let's have a look at what we can do. So let's substitute. V2 is equal to 3 plus J2. V3 is 2 minus J times 3 or 3J. And plus V1 is equal to 3 plus J. So now, in the denominator, we can add up our like terms. So that's going to be 3 plus, I prefer to write it as 2J so we don't get confused with the square there. And here in the denominator, we got 2 plus 3, that will be 5 minus 3J plus 1J is minus 2J. Alright, so now we add it up. We need to leave our answer in polar form. We need to simplify this here. So now this is 3 plus 2J divided by 5 minus 2J. So this is division in rectangular form. Okay, we need to divide. So how do we divide in a rectangular form? We multiply the numerator and the denominator by the conjugate of the denominator. Right, so remember, conjugate of the denominator. So what is the current denominator? It is 5 minus 2 times j. So when you are finding the conjugates, what happens? I got my 5, 2j there. So what happens is the negative will change to a positive. Only for the coefficient of j, not for your real number there. Okay, be careful. Only this sign will change. So it's 5 plus 2j. Whatever you do in the bottom, you must do on the top. So remember, this is conjugate of the denominator. Now, what can we do? We have to multiply out the numerator, multiply out the denominator. The denominator will always be the difference of two squares because we are multiplying by the conjugate. If this is x minus y, this is x plus y. It's a difference of two squares. These two are the same. These two are the same. The only difference is the sign here. Right, so let's multiply out. So the numerator, so what do we have now? We got 3 times 5, which is 15. 3 times 2j will be 6j. 2j times 5 is 10j, and 2j times 2j is plus 4j squared, because you got j times j, exponent law, j squared. The denominator is the difference of two squares, so that's going to be a squared minus b squared always. If we are finding the conjugate, it will always be a squared minus b squared. There's no need to multiply it out the long way. Right, so let's see what we have now. So we have 15, then we got 6j plus 10j, that will be 16j, and then we got plus 4 times j squared there, and then we got 5 squared, which is 25 minus 2j all squared. 2j all squared, that will be 4j squared. Okay, so now I got my, now remember here, j squared, there's my j squared. J squared, if you forgot your complex numbers, j is defined as the square root of -1. So therefore, if I square both sides, that's exponent laws. So j squared, when you square the square root, will cancel, and you end up with just -1. So wherever you see j squared, you're going to substitute -1. Here, let me do it one time. J squared is -1. Right. So now we have 15 plus 16j minus 4, and here we got 25. Negative times a negative is a positive. So now 15 minus 4, that will be 11 plus 16j divided by 25 plus 4 is 29. Right. Now let's simplify this. So that will be 11 over 29 plus 16 over 29j. Right, so this is simplified in rectangular form. So let's write this down. This is simplified in a rectangular form. But what did the question require us to do? Leave the answer in polar form. Okay, so we convert from rectangular to polar, and all the calculators can do that, but we have to show working here. It says show working. Right, but you should know, you'll know how to do that on the calculator. Give me the calculator there. Right, so if you want to convert from rectangular to polar on any one of these calculators, then you have the plus button and the minus button. If you look at the small yellow writing there, above the plus button you see POL. So that's converting to polar form, and the other one is REC for rectangular form. Okay, so what do we do? If we have to convert this, let's see, 11 over 29. Let me see if I remember how to do this here. Comma. So I'm getting R is 0,669 and theta is 55,49 degrees. So R is 0,6695. So all you're going to do is you're going to go shift plus. You go shift and you press the plus button and you see POL appears there. Right. So you're going shift plus and you can see POL open brackets. What you will now type in is 11 over 29. So that will be the real value there. So you go 11 over 29. Move your arrow to the right. Now you're going to press shift and the close bracket button, which is the comma in yellow there. Can you see that? Now you will input the imaginary value there, which is 16 over 29. And now move your arrow to the right and now close the bracket as just close your bracket. Okay, so on the calculator, this is what you are doing. You're going POL 11 over 29, the comma with shift comma and close bracket, and then you got 16 over 29, and then then you press equals to, it says R is equal to 0,6695 and theta is equal to, move your arrow to the right to see theta. Theta being 55,491.5. Right, so that's converting from rectangular to polar. So how do we do it without using showing all working? So now remember we got R is equal to A. Sorry, this is your Z is equal to A plus JB. So if I want to find R, I use the theorem of Pythagoras, so that will be the square root of A squared plus B squared. So that will be the square root of 11 over 29 all squared plus 16 over 29 all squared. What do we get there? Give me the calculator. So it's 11 over 29 plus 16 over 29. We get the square root of 377 over 29, which is equal to 0.6695, exactly what the calculator gave us. You can see that? So that is your R, sorry, that is your R, which is called the modulus. And now the angle, how do you get your angle theta? Okay, you need to make sure that you know which quadrant your angle lies in. It could be in the first, second, third, or fourth. Clearly it's the first quadrant because, let's see, you do a rough sketch here. So that's your A, that's J. This is called the Argand diagram. But we're not doing it for marks here, we're just doing a rough sketch to determine which quadrant we are in. So what is your A value? It's 11 over 29. The fact is, it is a positive number. Okay, so your A value, 11 over 29, it's a positive number. 16 over 29, the imaginary value is also a positive number. So the coordinates, there's it here. There's your 11 over 29 and 16 over 29 in rectangular form. Can you see that? So you draw a line, a vector from the center to that point there. And what are you doing now? You are forming a right angle triangle, and there is your theta, and there's your R. Okay, that's what we just found now. Using the theorem of Pythagoras, I found R is equal to 0.6695. And now, to find the angle, you got the adjacent side and you got opposite side. So this is the first quadrant. So we know that theta is going to equal to inverse tan B over A if it's the first quadrant. Okay, one time. Theta is equal to inverse tan B over A. What is B? What is A? B is the imaginary part. A is the real part. The real part is the part that does not have any J or I multiplied by it. So you're going to go inverse tan B over A. There's my B, which is 16 over 29 divided by A, which is 11 over 29. So let's do it and see what happens. So that is 16 over 29, 11 over 29, and we get 55,491 degrees. Exactly what the calculator worked out in a few seconds. Right, so this is showing all working. You use the theorem of Pythagoras and you use the tan. Tan is opposite over adjacent. We use tan all the time. Okay, because we're always given the opposite side and the adjacent side when you are given rectangular form. So there's no need to go and use sine and cos, but you can. Once you find theta, once you find r, you can use anything you want. Okay, we just prefer to use tan because we are using the given information. If you are using sine and cos, that's opposite over hypotenuse. What did we just find here? We found the hypotenuse, which is r. And if your hypotenuse is wrong, that means your angle will be wrong. So that's why it is not advisable to use r. Use the values that were given to you, which is A and B, which is opposite and adjacent. That is a right angle triangle. Right, so therefore, final answer, therefore, your BT is equal to, remember what we did, we converted it to polar form. What is your R here? Your R was 0.6695. Your theta was 55,4915. Okay, we normally round up to 3 decimal. Let me just round up to 3 decimal places, so that's 0.67 now. Because the 9 cannot change to a number it's changed to a two-digit number, which is 10. So that's 0,670. This is 55,492 degrees. So that was one way of doing it, which is doing it as it is, as it was given to us. Substitute, add it up, we come to a point like this, where we had to do division, and then use division in rectangular form, which is multiplying by the conjugate. So you could have, if you wanted to, you could have converted both into polar form here, and then do division in polar form. Okay, Richard, let me just do that now, while we're on this example. So that is an alternate method. You can see there's much more work involved in complex numbers for 5 marks compared to differentiation, where you can get 7 marks in one line if you know the formula for all your table of derivatives, the ones I told you to memorize. Remember, do not rely on the N4 formula sheet. It's not a proper formula sheet. Those are just examples. The formulas that I gave you on the board for calculus, that's the one you need to remember. Right, so what happens if you decide now, you substituted V2 plus V3 divided by V3 plus V1. So what do we have? So we have V total is equal to V2, which is 3 plus J2 divided by V3 plus V1. And then we substitute and then we add it up. What does it become? 5 minus 2J. I'm talking about this part here. Yeah. 3 plus 2J as the numerator, 5 minus 2J denominator. What happens now? You're seeing the word polar form there, so you decide, let's convert everything to polar form. There's nothing wrong with that. You can do that. So what we need to do is take 3 plus J2, convert it to polar, and convert this to polar too. So we got 3 plus J2. We need to find R and theta here. So we know that R is equal to the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is 13. Okay. Then your theta, you do a rough sketch, you can see both A and B are positive, so therefore it's the first quadrant. Okay, the next one I'll show you the diagram. So therefore theta is equal to inverse tan B over A, which is 2 over 3. Give me an answer there for that one. Inverse tan 2 over 3. Give me up to 5 decimal places. 33. That's it? 33,6. Read 5 decimal, 5 significant figures for me.
690067.
Right, so let's leave it. We're not rounding off here. This is not the final answer. Right, so that's 33,690067 degrees. So that is sorted out. Then what about 5 minus 2J? Let's call this R2, theta 2. So here, your R2 is equal to the square root of 5 squared plus minus 2 all squared. That is 25. Minus 2 squared is 4, so that will be the square root of 29. Alright, you can always confirm this all with the calculator. Now we want to work out theta. So be careful for this one. It's not the first quadrant. So that's your J minus JP minus A. So yeah, there's your real number, 5. So it's a positive 5. Here's your imaginary number, minus 2. So going up is positive, down negative, there's minus 2. Can you all see that? It's like plotting x and y. It's just that x is now called real, y is now called unreal. Right. So there's the coordinate 5, 2 here. When x is 5, y is minus 2. That means when a is 5, y is negative, j is negative 2. So there's your rectangle. You can see that. There's your rectangle, and there's your polar form. So therefore, it's in the fourth quadrant. This is the fourth quadrant. So we're going, your angle is measured from the positive x-axis, so we're going 90, 180, 270, and it's in between 270 and 360. So, what do we do? In this quadrant here, fourth quadrant, we're going 360 degrees minus, it's or 270 degrees plus, but then that's another thing we need to deal with. Now let's deal with that. It's best to use either 180 minus, 180 plus, or 360 minus. So you're going 360 degrees minus inverse tan b over a. Positive, positive. If you're using 360 degrees, when we are in the calculator, you ignore the negative sign. So that's going to be 360 degrees minus inverse tan b over a. So although it's a negative 2, when you bring it on the calculator, you substitute it as a positive. This 360 minus takes care of that negative sign. Okay. So give me the answer there. 360 minus inverse tan, 2 over 5. Oh, I got the calculator right here. So we're going 360 minus inverse tan. 338,19859. Right, so this is the working out to convert from. It's a lesson on converting also from rectangular to polar. So watch what's going to happen now. Right, so 3 plus j2 is no more 3 plus j2. It's now, where is your r? It is the square root of 13, and your angle here is 33,690067 degrees. Okay. 5 minus 2j. We converted it to polar form. Your r was square root 29. And your angle is 338,19859 degrees. Okay, so that's converting. Now we need to divide. So we had a problem here with division. So in order to divide in rectangular form, we have to multiply by the conjugate. Okay, there's no direct rule that can enable you to multiply, to divide. So therefore, you have to multiply by the conjugate. But with polar form, you can divide. So all you do is your r value on the top divided by the r value in the bottom. So that's going to be square root 13 divided by square root 29. And what do you do to the angles? It's going to be top angle subtract bottom angle. So that's going to be 3,690067 subtract 338,19859 degrees. And then let's see what we get here. So basically this is, let's just write this down, the square root of 13 divided by the square root of 29. And you get exactly what we got there, which is the square root of 377 over 29. You can see that, let me just round this off, which is 0,6695 there. So you can see there's a just 0,6695. We are top divide by bottom. Exactly the same thing there. You can see that. Now let's do the subtraction. Your angle is going to be different now. You need to understand why. So that's 33.690067 minus 338.19859. We get a negative angle minus 304.508523 degrees. So this is trigonometry now. We have a negative angle, but all final answers must be, it must have a positive angle. Basically, your angle must be positive. That is not written down here, but most of the time it is in the exam. So, if I have a negative angle, like minus 30 degrees, right, so basically what it means is you are measuring in a clockwise direction. So here is 0, minus 30 is going down, so there's your minus 30 degrees. Right, so this is 30 degrees in a clockwise direction. But if we are going in an anti-clockwise direction, that means we're going 90, 180, 270, and then what will this angle be? What do you think? If from here to here is 30 degrees going down, but if I go from 0 all the way around to the same position, what will this angle be now? It's going to be 300 and, remember it's in between 270 and 360 degrees. This is 330 because 330 plus 30 will give us the full 360 degrees. So the lesson to be learned is that if you want to convert from a negative to a positive angle, you always add 360 degrees. So I didn't show you. Basically all you're going to do is plus 360 degrees. Right, so which gives you 330. So whatever you have here, just go plus 360 degrees. So therefore this is equal to 0,67. And if I add plus 360 degrees there, I mean that's 55, 491. I'm getting 491 here because I round up. But anyway, 55,491492. That is correct. Alright, so this was a lesson on converting from rectangular to polar, from polar back to rectangular. In fact, almost the whole section is done here of complex numbers in just this one example. Only thing we didn't do the De Moivre's theorem. Right, but you can see there's a lot of work here, but it's not difficult. It's just that you need to know the terminology and the technique, what to do. And we continue with the next example. Right, so the next question, 3.5, solve for x. So what is this? X squared, that is a quadratic equation. Now this one is 4 marks. I'm wondering why is it 4 marks? Okay, because normally you have ax squared plus bx plus c. There's no middle term of x here. Let me just double check. Did I do it wrong? No, I'm not wrong. The question is x squared plus 1 is equal to 1 over 4. Clearly, maybe the examiner forgot to put an x here. Or maybe an x this side. Okay, but because this one is too easy, I'm going to show you why it's too easy now. For 4 marks, this was a luck in the November 2020. Because all you're doing is solving for x here. So, x squared is equal to 1 over 4 minus 1. You can see that? So, x squared is equal to 1 over 4 minus 4 over 4. So, x squared is equal to minus 3 over 4. So now, we find the square root of both sides. Remember that when you are finding a square root, there are two possibilities. So you must put both plus and minus. Okay, now what do? You have a square root of a negative, which is undefined. So if you were in N3 or something, you're going to stop here, and then that's that. But now we use a substitution for that undefined part. What is the substitution? We just did it here. J. Remember that J, or you can use the letter I, is equal to the square root of negative 1. Right, that is the substitution that we use in complex numbers. So we need to get the square root of negative 1 here. So I'm going to write, so that's x is equal to plus or minus the square root of. So you got minus 3 over 4. It means minus 1 multiplied by 3 over 4. Multiplication. Alright, so now I can split this up into two factors because minus 1 is being multiplied by 3 over 4. So that's going to be the square root of negative 1 times the square root of 3 over 4. So now you know that j or I is equal to the square root of negative 1. So you're going to say let the square root of negative 1 equal to j or I. It's up to you. So therefore, x is equal to now plus or minus j times this here, which is the square root of 3 divided by the square root of 4. So that's going to be plus or minus j square root 3 over 2. There's nothing in front, so it's a 0. Okay. So therefore, x is equal to 0 plus or minus square root 3 over 2 j. That's your 4 marks without a calculator, but they did not say do not use a calculator. You can use your calculator. So that was your 4 marks, 3.5. Right, so let's complete this one first. Okay, that was our 3.5 for 4 marks. I'm just, it could have been done in a fewer steps. It's just that I'm trying to show all working here without a calculator, not for the exam but just for your understanding, to show you how I'm finding an LCD here. 4, 1 is 4 over 4. 1 minus 4 is minus 3. Then I'm showing you without a calculator how you split it up. Do your substitution, and there's your 4 marks. Then they ask you the next question for 1 mark. Give the conjugate of 1 plus 3j. So the answer there will be 1 minus j3 or 3j. Doesn't make a difference where you write down the 3. So that's done. That is your 1 mark there. Now, question 4, as I just said, I'm not going to be doing Kramer's rule on the board. Everybody knows Kramer's rule. That's a simple thing to do. 4.1 that will be 4.1, 4.2. Let's move to the graphs, which are very, very important for the higher levels. So draw the following graph and add the necessary labeling. Let me make sure I copied it down properly. So we got 25y plus 9x squared minus 225 is equal to 0. So look at this equation. You normally have a quadratic equation equal to 0. So what happened was here, they just took everything and left it on one side. Right, to see if you now get confused with this here. Are you able to manipulate this equation and get it into a form that you recognize? So what do I mean? We normally have y on the left hand side. So let's try, this is not y squared, it's just y. Okay, so let's make y the subject of the formula. So I've got 25y is equal to minus 9x squared plus 225. Okay. Maybe they were supposed to put a y squared and make this an ellipse. Okay. It seems like that, because why would you make a question like this here now? Where when you divide by 25, so look what's going to happen here. Y is going to equal to, I have to divide the whole equation by 25. So that's going to be minus 9 over 25 x squared plus 225 over 25. Okay. So now this is a parabola. Okay, it is a parabola because you got your ax squared. You don't have to have any other terms here. The fact is, if you just got the x squared, you know it's a parabola. Right, but this parabola will have x-intercepts and y-intercepts and a turning point. The turning point and the y-intercept will be the same. Right, so this parabola here, remember your parabola is in the form ax squared plus bx plus c. It's just that there's no bx now. Bx is missing here. But you got the a, which is minus 9 over 25 there. So this determines the shape of the graph, whether it's pointing up, happy face, or whether it's pointing down, which is a sad face. So here, your a, you can see, there's your a value there. And it is negative. So if the coefficient of x squared is negative, then it's a sad face. That's the shape of your graph. Okay. Now, you don't have to go and do a lot of working out here except the x-intercept. Let's see what the x-intercepts are going to be. So to find the x-intercepts, you're going to let y equal to 0. So I'm going to have minus 9 over 25 x squared plus 225 over 25. I'm writing down the 0 on the right hand side. Okay. So now I have minus 9 over 25 x squared is equal to minus 225 over 25. Okay. So now if I got 25 and 25 here, if I multiply by 25 on both sides, 25 will cancel there. Can you see it in your mind? If I multiply by 25 on both sides, that and that will cancel, that and that will cancel. You end up with minus 9x squared is equal to minus 225. So therefore, x squared is going to equal to minus 225 divided by minus 9. Give me the answer. What do we get? 25. So x squared is equal to 25. That means now I can find the square root. Sorry? 25 is correct, huh? Yeah. So I'll find the square root of both sides, which is going to equal to plus or minus 5. What about the y-intercept? Y-intercept, let x equal to 0. So if I go back to that original equation, there's a g here. If I put a 0 there, I'm left with 225 over 25. Which is 9. These values here, I can see that probably there was a typing error in this paper here. Okay. Because if I was an examiner, I wouldn't set a parabola example with numbers like this here, 225, and it wouldn't be, we normally get smaller, you use smaller numbers. But maybe the examiner is testing you now. Is making you think that this is when you look at it first time, you might get confused, you might think it's an ellipse, but clearly there's no square. Right, so no matter what's given to you, you need to be able to manipulate it. That's why you manipulate a formula, you do manipulating formulas. So if something seems complicated, manipulate it, and then you say it's just a parabola. So y is equal to 9. Now, this type of parabola, you can find, if you want to find the turning point here, what will the turning point be? You can use calculus if you want to. Find dy over dx, make it equal to 0, or minus b over 2a. Minus b over 2a for your x value. But what? There's no b here. So what is b? 0. So that means the x value of the turning point will be 0, because 0 divided by anything is 0. Now think about it. Without doing any calculation, you know the turning x value of the turning point will be 0. To find the corresponding y value, where do you take the x value and substitute? Into the original equation. So if I put the x value here of 0, my y value is 225 over 25, which is 9. Okay, so the y-intercept is the turning point when bx does not exist here. Alright, so let's do a rough sketch here. We don't have to go and start measuring. Just do a rough sketch. Make sure it's labeled properly. So, we know that this is the shape of the graph. We know that this point here, the turning point, is the y-intercept. So there's your graph here. It's coming down there and down there. Label it, this is a parabola. What are the x-intercepts? What are the y-intercepts there? X-intercepts, we just found it here. You can see that. So that's a 5 and negative 5. On the x-axis, y is equal to 0. You should start labeling your coordinates, labeling your x-intercepts and y-intercepts in terms of coordinates. Okay. What is the y-intercept here? When x was equal to 0, y was equal to 9. So what else is there to do? Label your graph. Y is equal to minus 9 over 25 x squared plus 225 over 25, which is plus 9. So that was this question. The next question here is about which axis is the graph you drew in 4.3.1 symmetrical. So, which axis basically cuts this graph into two equal halves? That's basically what symmetrical is. So basically, if you're looking at this half and this half here, the axis of symmetry, this is a parabola. Okay, axis of symmetry is, what's it going to be? There's it, it's 0. Can you see that? Because there's a turning point. All you do is, if you want the axis of symmetry, it's the x value of the turning point. Same thing. So this cuts this graph into two equal parts. Basically, it's like a mirror. If you're looking at the mirror, what do you see? You see yourself. So it is the y-axis. Right, so make sure you are able to answer these type of questions. 4.4, draw and clearly label the graph of x is equal to half or 1 over 2 all raised to the power y. Okay. So, when you are sketching a graph, you are used to having y as the subject of the formula. So, make y the subject of the formula. How do you do that? How can you make y the subject of the formula? Because now, identify y in this equation. What's its position here? It is the exponent. So therefore, if I want to make that exponent the subject of the formula, I need to try and make the bases equal so the bases can, so I can equate the exponents. So that is the first thing we always try and do. These bases, this base is x, this base is half, there's no way you can make them equal. So that method is out now. So if you cannot make the bases equal like you did in N3, then you introduce logs or ln. So it's up to you what you want to do. Logs or ln on both sides. But now remember, for future, for N5 and N6, we are encouraging you to use ln natural logs. Okay, because of differentiation and integration, it's much more easier to deal with ln. And when you introduce ln, remember it's going to be on both sides. Okay. So that will be ln x, and that will be half all raised to the power 1. So you introduce ln or log on both sides. It's the same rules. So we got ln x, and now what we can do is we can bring down this exponent, so it becomes y ln half. Now I can divide on both sides by ln half. So that's ln x divided by ln 1 over 2 is equal to y. Right. Now, you could have done this in one step also. Right, so what do I mean? Remember, if you have ln a to the base b equal to c, then a is equal to b to the power c. So what we have here is a is equal to b to the power c. A is equal to b to the power c. Can you see that? So I can do this in one step. I can go now, check what's my a, b, and c, and go one time. So, and write it down. So c is the power here, which is y. Can you see that? So if I go y, c, then I go ln a to the base b, ln a to the base b. So it's going to be ln x to the base half. Now watch here. That is in one step. Okay, that's doing it in one step, converting from log form to exponential form. Or in this case, converting from exponents to log. That's what they teach you all in grade 12. I noticed that. They don't show you all the log laws. All you do is you convert from one form to the other. Here, I'm showing you that how you introduce logs on both sides, or ln on both. You must learn it this way. We're going to be doing it in N5 a lot when we're dealing with calculus differentiation. Okay. So you must understand that you introduce ln on both sides. And now what happens here is, when you got ln divide by ln, the bases are the same, you can write it down as ln x to the base half is equal to y. Alright, so now, why did we do this? Because we wanted y to be the subject of the formula, so we know we are dealing with log graph. It's a ln graph. So be careful, your theory on log graphs now. Be careful here. If you have ln a to the base b, so this is your base, which is b. So you need to check your base. If your base is greater than 1, basically you can have two options here. Your base can be greater than 1, or your base can be in between 1 and 0. In between 1 and 0 is 0.1, 0.2, like here it's 0.5. Half is 0.5. Now, what do I mean now? What's going to happen here? If it's greater than 1, it's going to be increasing. It's an increasing function. If it's in between 0 and 1, it's going to be decreasing. Okay. So that is the shape. Increasing, decreasing. What do we have here? We have a base of 0.5. 0.5 is a number in between 0 and 1. Notice your base must never ever equal to 1, because log of 1 is 0, and you're going to get an undefined result. Alright, so now, that's a log graph or ln graph. It will come out many times in N5, N6, especially in N6. All these things that we're doing now. Right, so let's sketch our graph. Okay, so now, what do we have? y is equal to ln x to the base half. This is our graph that we are dealing with. Now, without doing any calculations, okay, if you got ln x, your base is a number in between 0 and 1. It's just a rough sketch for 2 marks here, not for 20 marks, where you're going to go and start drawing a table and substituting values. If you want to, you can do that. Okay, but the fact is, you need to just make sure you know the basic shape of the graph and the critical points here. So this is a decreasing function, so it's going to come down. We have an x-intercept. The log graph is the inverse of an exponential graph. If you take your page and rotate it 90 degrees to the left, you'll see this is just an exponential graph if you rotate it. Basically, this is an inverse of your exponential. So what is the x-intercept of the graph? How do you work out an x-intercept? Right, so for your x-intercept, let y equal to 0. Now, look, I can do it here if I want to. Let's do it here then. So I'm going to go 0 is equal to ln x to the base half. So basically ln x to the base half is equal to 0. So I want to solve for x here. So all I will do is go to my standard form here. Ln a to the base b is equal to c. This time I convert from logs back to exponential form, which is on the board. It's right here in front of you. I'm going to show you now. So what is it? X is equal to half to the power 0. The base of the log becomes the base of the exponent here. So half to the power 0 is 1 here. So this is a1, 0. Now look here. If you go back to the equation that was given to you, if I put y equal to 0 here, it's the same equation, remember that? Y is equal to 0, there's it. So you can see that x is equal to half to the power. I went back to this equation. Now, for logs, you need to show at least one more point on the graph besides the x-intercepts. At least one more point on the graph. So you can choose any point you want to. So let me just show you now. We've got x and then we've got y is equal to ln of x to the base half So we know that when x is equal to 1, what is y equal to? 0. Let's try a few more values there, just for practice. When x is equal to 2, what is y going to equal to? You can use your calculator if you want to. Put ln 2. So now, when x is equal to 2, y is equal to ln 2 to the base half. We got a problem now on the calculator, am I right? You got a problem on the calculator because you cannot find this function on the calculator that allows you to change the base. But if it was logs, then you have that button on the calculator. So how do you do something like this here? What you need to understand is that if you have ln a to the base b, since the calculator does not have the function to change the base for ln, so you will write it as ln a divided by ln b. So therefore this is going to be ln 2 divided by ln 1 over 2. Right. I can even do this without a calculator while you're busy there. So that's going to be ln 2, and that's going to be ln 2 to the power minus 1. So that's ln 2 minus 1. Ln 2 and ln 2 cancel, you must get negative 1. Correct. So therefore, when x is equal to 2, y is equal to minus 1. Just another point on the graph to make sure that you are on the right track here. Right, so if this is 1, yes, let's put 2 here. That's 2, and there's minus 1 here. So we got a point 2, negative 1. We don't have to use the 0.2. You can try 3, you can try 4, as long as you substitute an x value and the output is the correct corresponding y value. So that is for your log graph. Right, so that was our log graph.